really want to be recorded, you're welcome to put your questions in the chat, and one of us will facilitate those as they come up or at the end, whatever works best. Yeah, Rich, you're welcome to introduce yourself.
Great. So Danielle, I'm going to go ahead and start sharing my screen. Jenny, do you want to go ahead and start? Oh, we are recording. Good, great. Let me just share here. Minimize this. Great. Well, my name's Rich Stromberg, and I am on the board of directors at Cold Harbor Institute. One of my other roles is that I am the program director for the Equitable Solar Solutions program at Cold Harbor. And what that program is about is that we take reuse solar equipment and we test it, check for any defects, assure we have good quality, and then we place it back in service for low income households and communities. And then the equipment that we test, if we don't believe it's at that top level for rooftop installation for the next 20 to 25 years that we don't have to worry about, we'll downgrade that to what we call a tier 2, which is still very good. A lot of potential use for that. But we just don't want anyone to ever have to climb up on a roof and troubleshoot with a voltmeter kind of thing. And so that's what we're here to talk to you about tonight, is this tier 2 solar equipment that is still very good, very functioning. We've tested it well, and we're going to show you some applications of what you can do with that. And we currently have solar modules, PV modules that are available both in 12 and 24 volt applications. James, you want to tell us a little bit about yourself?
Yeah, good evening, guys. My name is James Cody, and I'm a graduate fellow for the Equitable Solar Solutions, finishing my master's in environmental management degree here at Western Colorado University. Tonight, we have a little bit of video coming your way from some interns and myself and Rich working on some small-scale PV setups. Do bear with us. Although the Oscars were just this past weekend, we are not professional directors, so there's a hang tight with us, but I think you guys will enjoy. And yeah, thank you again for joining us.
And folks will be monitoring the chat in case we do have some questions in the interim. We'll have more time for questions at the end. So here's our flow, what we're going to cover. We'll talk a little bit, give you a little bit more detail about our program, a bit about safety that you should know on these modules. And then we've got a bunch of different short videos with various topics. And then we've got a Q&A. On these slides too, I think we'll find, Danielle, Jenny, there's probably some way we can share the slides. There's a bunch of backup material at the end in case questions come up, but the actual slides are pretty short, but we can get that information to you. And we will share links for some of the stuff in the chat as well. Okay, so I told you just a little bit about who we are. And we're hosting this webinar now because for more than a year now, we've been testing our solar panels that come in. We have some other equipment that comes in as well. And we do have some inventory of panels that are still good, still functioning, but we just are not going to apply them to rooftop systems. They're much better for being outdoors on a ground. In fact, they're all outdoors, but say on a ground mount system, maybe ag purposes, doesn't have to be ag, but certainly if you're out in a field and cattle are rubbing up against your modules and stuff like that, it's not going to hurt anything at all. These things will take a beating. They're quite robust. But it's also easy if something were to go be an issue in the future, you could always just walk up to them, unscrew the back junction box cover, and just test some things and make sure everything's running fine. But our contact information, you can email me at ess@coldharborinstitute.org. And you can also visit our website. The specific page for Equitable Solar Solutions is at this link here, and we will share these in the chat. All right, so what we will cover is we'll give you a background, which we of our screening too. In fact, I'll just go ahead and tell you about that now. We do a series of visual tests when we get them in, looking for there's certain just visual, a lot of cosmetic defects that we'll make note of, but should not affect performance at all. We will do electrical testing on the modules under known temperature, known irradiance. We'll check the open circuit voltage, the short circuit current, and then we will also do a backside thermal imaging under short circuit conditions. And with all this, we're able to tell how much the modules have aged. If there was any performance problems, that would certainly get screened out in that process. And so every module gets a certain level of testing, and so we know and we do find occasional ones that are just flat duds. They don't work. We can use them for display, but we got a donation and some modules got struck by lightning on this array. Every one of them was bad. So that's not what what we have here. Some of the modules are only a few years old. We have some a bunch of solar modules donated by Bank of Colorado in Boulder, and they were only 8-year-old modules. Why would they get rid of 8-year-old modules? Well, there was only so much space they had on the rooftop. And back when they installed these modules in 2012 or so, the average module was about 15% efficient by surface area. Well, now you can get modules that are 22% efficient. And so the bank decided to put in all new modules, and we got the old ones. So not even 20 years old. Typically, a module loses on average about 1% per year in total output. This means after 20 years, you should still get 80% output. Now, some manufacturers are different from others, and that's one reason why we do the testing that we do to understand Kyocera versus Conergy versus PhotoSolar, all these different ones, how they do over time. But we do that detailed testing, and some of the modules are 20 years old, but some are only a couple of years old. So that's what we've got. And then we will cover some common applications of using these 12 and 24 volt modules in Gunnison County. And then I'll also show you some good links for online suppliers to order equipment you might need if you have to do batteries or charge controllers, things like that. Some of the applications we will show you, it's literally directly the solar module to your load with your wire and a fuse in between, and it's just that simple. Others you might require a charge controller and a battery, and we'll kind of elaborate on those and make sure you know what we're talking about. And then we won't get into great technical specs of wiring and connecting your application. We do have a technical workshop that we conduct about once a semester. That's 6 to 8 hours. That gets you started. And then there's other training you can do too if you really want a lot more detail, like Solar Energy International has a PD 101 course that's great. All right, just a few safety things to keep in mind here is that National Electric Code defines low voltage as anything that's less than 50 volts. In fact, you don't even need to pull a permit in Colorado if what you're building is less than 50 volts. Anything 50 volts all the way up to just less than 600 volts, so 599.99 volts is medium voltage, and that's treated differently. And it's a higher level of risk, but that's why we have electric codes and wiring stuff that you have to follow and those kind of things. Typically, you would want to pull a permit if you're doing anything like a permanent, a fixed installation. We would advise that. And then when you're using batteries, some of the applications, you'll want a battery on your system for gate openers and electric fence chargers and some of the other applications that we have. You could, some batteries are optional, others that you just flat need a battery in your system. Whenever you're working around batteries, be mindful, what's the distance between the positive and negative terminal? You don't want to be using any metal tools that are long enough that if you accidentally dropped them and just Murphy's Law shorted your tool across those two terminals, the spark is incredible. It can literally weld that tool to the battery. There's so much current transferring across those terminals in that short split second. It can also cause a major arc, could blind you, that kind of stuff. So make sure your tool is either too short to short across those to connect those two terminals, or you'll see electricians will wrap a lot of the from the handle on to just right before the tip, they'll wrap it electric tape, so there's no way they can get a short there. So important safety tip when working around batteries, they can be nasty. And then we always recommend installing a fuse on the positive lead wire of whatever load you're connecting up. And we'll cover that. I have one slide where we can talk about the sizing of your fuse and stuff. Okay, so we're going to show you some videos here, and I'm going to break out of, I'll be going kind of back and forth into the PowerPoint into the YouTube video. But let's go with, is this our video? All right. Hi folks, Rich out of Clark Ridge. Just one, and one thing, I bet you couldn't hear that. I'm going to stop share for a second, and I'm going to reshare so that, because I forgot to check the box of share computer sound. So I will reshare again. And we have a little bit of wind noise in the beginning of this. Just bear with it. We can always answer some questions for stuff that might not have come across. And today, I'm out here to show you some modules available that if you make a donation to Cold Harbor, we have some reused modules that we've tested. Electrically, they're very good. We found some minor flaws, a little cosmetic mostly. We think they still have a lot of life in them based on this is a 80 watt module here, photo watt, made in France originally. And so this module or say maybe you just want to direct wire this into a 12 volt fan or a 12 volt LED light system or a 12 volt pump, whether it's a diaphragm or a flow pump. So anyway, it's already got, this one's pre-wired. You'll want to actually open up the junction box and wire in probably your own length of cable and set it up like you want. If you need more power than just a single 80 watt, you can wire these in parallel, and it's still going to be that same 12 volt application. You just get more amps out of it. But anyway, good module. You can see it's still in great shape. This makes about 80% of the original power. Its module was made in the early 2000s, so it's almost 20 years old now, and it's just a little bit more than 80% of original power. This one's a beast. The frames on these, it's a little bit heavier. Frames on these are really sturdy. This is Solarx. Back in the 80s, Solarx was the top PV module manufacturer in the US. And it's because they had learned how to mass produce these types of cells, which are called polycrystalline. And they did that a lot cheaper. That's how they were so successful. The frame is really heavy duty. Good solid backing here as well. Again, it's got a junction box. You want to open that up and wire for your application. This is also a 12 volt application too. Let me show you the other 12 volt module. This is Kyocera. Kyocera is still very much in business selling solar panels. They are the Cadillac line here. And this module is great. We found one little nick on the back side, and so we're gonna just kind of put a little bit of sealant in there to make sure the moisture stays out. But electrically, this is still really good. This is making about 87% of the original power of when it was brand new. Kyoceras have aged really well. A lot of modules, they lose about 1% per year, but the Kyoceras are doing better than that. They only lose about 0.7% output per year. Great modules though, and again, junction box on the back. And a lot of these modules actually come with the weather-tight connector, but you may, depending on what you're doing, may need to get slightly different size for the size of cable, whatever. But good module there, again, for 12-volt applications. Last one, this beast, this is a 200, so that was 120 watts on that Kyocera. It's 60 watts on the Solarx, 80 on the PhotoWatt, and then this is a 230 watt module from Conergy. Conergy's still making modules. This one, I think, is making 91% of brand new. This is a donation off of Bank of Colorado in Boulder, and they gave us their old modules. But this one, you can see back here, slightly different setup. If you were going to, you can actually open up this junction box and get at it, or you could use these existing wires. This module actually puts out 28.8 volts under load, and so you wouldn't want to use it for a 12-volt application like we've shown you in most of our demo videos. This would be for, say, if you had a stock tank heater that was in the 24-volt range, or if you had a ventilation fan for one of your growing buildings, livestock buildings. Those fans, you can buy those online, DC fans that take higher voltage. So you could directly wire into either of those loads, or if you wanted to set up your own mini cabin system, you could use 24-volt modules with a charge controller, 24-volt battery bank, and then a 24-volt DC to AC inverter, run all your normal AC loads. But this is a great module as well. Just wanted you to see what some of our inventory looks like. Again, all of these modules, we have tested them electrically, and electrically they're fine. That's all. Thanks. Okay, folks, we'll pause just a minute to find out, James or Jenny or Danielle, were there any questions on the chat so far? Otherwise, we'll go on to the next video.
There are no questions in the chat, but if anybody would like to just jump in, you're welcome to also switch your camera on and ask questions.
Okay, we'll go on to the next video, and then we'll keep checking. Thanks.
All right, hey everybody. We're out here at the Cold Harbor Institute today. We're going to show you how to set up a simple solar water pump system. This is a super standard 75 watt panel. The pump we've got down there is 12 volts, and this panel is rated for 17 volts. So obviously, if you're going to have this set up out in the weather, you're going to want to have the proper UV rated wiring and some better connectors. But yeah, it's super basic. And yeah, I'll hand it over to Austin to show you how it works.
All right, guys. So all we really need to do to start pumping water here is complete the connection. Down here we have the positive and negative wiring. Just got to take this cap here, wire everything up, complete the connection. I get out of the way of the panel, and water starts pumping. Simple and easy. This is a really great system, guys. All you need is 4 major components. You need a panel, access to direct sunlight, the pump itself, and a body of water, and you're good to go. You got water on your property, rural or municipal. Hi guys, as you'll see here, we have the same system as before, but on a slightly larger scale. You'll see here that we have 2 100 watt panels as opposed to a single 75, but all the same principles apply. We're still pumping water, we're still moving it around, and it's still great for your rural property.
And yeah, if you'd like any more information about this setup, please feel free to reach out to Equitable Solar Solutions.
Okay, on that, I'll add a couple things. They were demonstrating a flow pump, and flow pumps are more efficient at moving high volumes of water, but at low pressure. So, so you'll get more gallons per minute move from point A to point B, and you can actually, go uphill as well as just going laterally. You'll need to look at your pump specs to see what kind of elevation head you can push with that pump. And that will really kind of define how many modules you need, and they'll let you know, is this pump a 12 volt, a 24 or 48 volt, or even higher rated pump or required pump, and then how many amps are the max. And so you might need more than one module to meet either the voltage or the current load for moving the water. It just depends on your specific application. How far are you moving it? How far uphill? What kind of volume you want to move? So we got that. And then there's another type of pump also that's a DC pump, and that'll be your diaphragm pump. And those, you'll typically see those on RVs, but they're also sold at the ranch supply stores as well. They're kind of a little bit large. In fact, it looks just like this. This is a diaphragm pump here. But they come in various sizes. I typically see them in 12 volts, but they also come in 24 volt models. You'll just have to check and see which one you want versus if you need 24 volts, you can always take two 12 volt modules and stack them in series and get 24 volts in your system to run that pump. But those are needed for when you need pressure. They still move a fair volume of water, but they're more for pressure. And so the other one's a submersible pump. The diaphragm pump sits out of the water. And so you would like fill up a water tank, kind of a holding tank from, say, Tamichi Creek or whatever, with a flow pump. And then that water tank, you would then attach your diaphragm pump, and you could run sprinklers and things like that, or drip system off of that. So we've got that. And then they were using wire nuts to connect up that pump. I do have one slide at the end of the slide deck that shows what a Hopkins quick disconnect looks like. You'll see those in the auto parts store for trailer towing, that kind of stuff. And you can use that to just do a quick disconnect and reconnect instead of having to manually twist a wire nut. Okay, we're going to go on to the next video now.
Hi everyone, welcome back. So today we have two greenhouse applications for you. One is a small circulation fan and the other a greenhouse light. So here we have two panels set up on a very simply constructed wood frame, which can be put up quickly with any scrap wood laying around the farm. And you can contact Equitable Solar Solutions for any questions about alignment, and we'll help you there. So the panels are both 75 watts with enough current to power two 12 volt DC fans, which you can see right there.
And over here we have a 12 volt LED fan that can be powered with a solar module right here. So the first thing you need to do is you need to look at the color of the wires, and you need to set the white wire to the white wire and the black wire to the black wire, or the corresponding colors. There could be a few different ones. You can flip them around and find out which one. It shouldn't matter, but you just connect them, each wire to the other wire, and then once you do that, you can connect this permanently with solder or wire nuts.
Yeah, and I'll add that. So in lighting, let's say you are using a greenhouse. This is real good for during the daytime. You wouldn't need a battery if all you needed was some supplemental lighting. And they do have DC grow lights that you can buy online, and you can just wire those directly in. So you've got your natural light coming in, but let's say you need either for germination or at different growth flowering stages, you want additional lighting for a certain number of hours a day. So you can mount your modules to the time of the day to optimize the sun. So maybe you want some more morning light or more afternoon light. You can actually orient your modules that direction. If you don't have any preference, just have them somewhat south facing with, say, latitude tilt. One thing I'll point out on the fans in in the high tunnel that was there on campus is those two modules are actually pointed to the southwest. And we did that because later in the afternoon, beyond noon, is really when we have the highest temperatures of the day. And so that's when we're going to get the fans. The video showed the circulation fan, but at the gable end of that high tunnel, there is a ventilation fan to vent out that excess heat in the high part of the high tunnel. And so in the afternoon, when it's really hot, we have the modules pointed to grab the most amount of sun to run that fan as fast as possible. And that fan is also on it is on a thermostat that's set around 75 degrees, so that when early in the morning, you don't want to vent out warm air, because you want that high tunnel in your greenhouse to warm up to a certain level from overnight lows. So we wait until it gets to about 75, and then we kick on the vent fan.
Welcome back, guys. Right now we're going to show you how to set up a small cabin system, or a system for your road trips this summer if you're living out of a vehicle. So right here we have a 75-watt panel from Equitable Solar Solutions. On the back here we can see that we have a rating of 75 watts, and we're going to have 4.4 amps. The reason you're going to want to take note of the ampage is when we move over here to our charge controller. These come in anywhere from 12, 24 volts. This is a 12-volt system, but the important thing to note is that it is only rated up to 30 amps, which means that no matter how many panels we have to make sure that the total ampage stays under 30, or else it will not work. This charge controller is connected to our 12-volt battery, which in turn is connected to our 80-watt DC to AC inverter.
800 watt.
800 watt DC to AC inverter. That in turn comes over here and is connected to our fridge. If you're looking to do something a little bit larger of a load, such as a microwave or an instant water pot heater, very simple fix to that. You can get you can have two batteries set up, and you can get a 24-volt in charge controller, and you can up the inverter to the specific size that you need to be able to power. Few things you want to note is that on our solar panels, right now we don't. This is a weather sealed connector that you're going to want to get if it's going to be outside, with UV protected coating. And then when you're working with tools around this, you're going to want to make sure you don't have any metal that's going to be long enough to cause a short, as that can be dangerous to your health and the people around you.
All right, and on that, I'll add that your charge controller and the DC to AC inverter, you would want those out of the weather, out of the elements. And so those would, since it is a cabin system, you would have those inside. Further, if your batteries are inside, you will want to, if your batteries are inside, you will want to use sealed batteries, not and sealed batteries can be lead acid, but you just don't want a conventional lead acid battery, because if it's not sealed, as the charge level gets higher and higher, they will start outgassing some hydrogen. And if you're in an enclosed space, that can create an explosive hazard. So I have the sealed batteries in my cabin up in Alaska. They're inside the cabin. It keeps them a little bit warmer, so they have more juice in the wintertime, and that's fine. They're not going to create a safety hazard, as well as my charge controller and my DC to AC inverter. I actually have a 2000 watt DC to AC inverter, and I can run my microwave. I can run an electric kettle off that, those kind of things. I also have 4 batteries instead of just a single one. But that was just a simple demonstration. In fact, it's exactly what I have on my Honda Element. So when I go on road trips, I can run my laptop. When I go to see an eclipse, I can run my motorized telescope, those kind of things. So it is a nice, handy little option for on the road if you're living in a van down by the river or anything like that. So That's the cabin system. You can size it much bigger than that if you have a true cabin with full-size refrigerator and all those kind of things to run.
All right, everyone, welcome back. Today we have two more applications for some solar PV and agriculture. We're going to be talking about stock tank water heaters and electric fences. Both of these can be used anytime the sun is out and shining, just like it is right now. And they also can be used off of a battery setup, which Taylor's going to explain a little further.
Yeah, so this is a stock tank water heater. It can run fully off of solar. It'll be connected to, discussed earlier, like a charge controller, a battery, and then your PV panel. And then as long as these are connected, it'll run off the battery at night when your water is most likely to freeze over for your livestock or any of your animals here in Gunnison. And then same thing for your electric fence. It'll keep running 24 hours a day as long as you're connected to the battery and the panel, and you'll have no problems keeping your animals in.
As always, guys, safety is first, so just make sure you're being safe and careful when setting these up and using the correct UV rated and insulated wires and cabling. Thank you.
Okay, and on that, so there's two ways you can run some of that. The stock tank heater, you could go very simple and just have the heating element. And she showed a version, you can buy the bulkheads for that. So you can screw it in to like a Rubbermaid or one of those type fittings on the tank. And the most simplest way is literally to just have a solar panel wired directly into one of those heating elements. And they come in 12, 24, and 48 volt styles or options. And the most simplest way is you just want to heat that water up during the day as much as possible so that overnight you've got some thermal mass in that tank that it takes longer for it to freeze up. Where it freezes up, the ice doesn't get very thick. So that would be your easiest application. You can do it with a battery, but you'll need to watch and see what's your battery capacity, how much that heating element is running. It can start getting kind of expensive depending on exactly where your stock tank is. If it's in like a shed with an overhang, that loses less heat than just all the way outside. Where you're storing your batteries, those kind of things. So probably the cheapest way, in fact, definitely the cheapest way to go is just get you that thermal mass during the day while you've got sun to energize that heating element and just let it go overnight. Of course, here in Gunnison, when it gets down to minus 25, minus 30, there'll still be some months, the coldest months, you will still be out chipping ice. Hopefully it won't be in fact, it shouldn't be as thick as without that heater, but you'll still have some periods where it will freeze up overnight. Whereas when you're on the Front Range, other parts of Colorado, it probably will carry you through the night. Your electric fence controller or fence charger, those things run in a pulse. And so it's not a continuous current. The current load on that heating element is quite high. And that's why you actually get better efficiencies with a higher voltage system. So your electric fence, since it's only doing periodic pulses, it needs a much smaller battery. And it takes a lot longer to draw that battery down. And of course, if you have your solar module, every day it's charging it back up. So that actually extends the life of your battery on your electric fence. Same with your gate opener. It hardly ever gets used. So it's got a small battery. In fact, those 80 watt modules and 75 watt modules, those are overkill for both of those. So you could actually, if you wanted to, have your automatic gate opener and your electric fence controller right at the same location. You could run them off the same PV module, photovoltaic module. Or let's say you had multiple pastures with each with its own electric fence controller. You could put the controllers both next to each other and do your fence perimeter and run both of those off the single module. So those are some options there. folks, Rich here, and I'm going to tell you about how to take your golf cart and make it run 100% on solar power. All it takes is a little foresight. Get it? Anyway, so what we've got here is one of our reused solar modules. This one's 120 watts. It is a 12 volt module, or 4 12 volt applications. Whereas if you look under the seat into our battery bank, we have 36 volts worth of batteries, which is standard for this size golf cart. You also have golf carts, the larger ones have 48 volt battery banks. So the biggest question is, how do you take a 12 volt module and get it to charge a 36 volt battery bank? I'll step around to the other side where I can show you a little bit better. The secret is this special charge controller by Genasun that is specifically made for golf carts. And it will take a 120 watt module, 12 volts. It will multiply the volts by 3, but divide the volts by amps. So you're still getting at full power 120 watts, but the voltage is stepped up to 36 volts, just at a lower amperage. And that's fine for charging up these batteries. This charge controller costs about $130. The other costs in the system are, we've got about 20 feet of PV wire, which is ultraviolet light rated. We've got a few connectors. We've got these nice little feet offsets to mount our module. We happen to get them to line up with the screw holes of where the roof mounts to the frame. But if that doesn't work out, you can just drill through your roof with a longer screw and get some washers, and it will hold on just fine. And that's really it. That's all you need on the system. So very low cost. You can do it for about $200, and then you never have to plug it in again. Okay, folks, so those are our videos. All just one slight mistake I made is that the Genasun takes your 12 volts on that 120 watt module, and it multiplies by 3 for the volts, but then it divides by 3 on the amps. So let's say there was 9 amps actually 12 volts, 10 amps, then you would get 36 volts and 3 1/3 amps. So the total watts are still the same, but the charge controller does a DC to DC conversion to step up those volts. So you've got enough voltage to be higher than your battery bank and charge up that battery bank. They also have a model that runs for a 48 volt battery bank, which is on your longer golf carts. So that's what we had for videos. And how are we doing? Do we have any chats? Any questions come in on the chat yet?
I don't see any.
Okay, great. So just a couple other things to be mindful of. I don't want to get too much down in the weeds on the technical side here, but you do need to be mindful of what are the amps of the load that you're running versus what's the wire size. Now, most of these PV modules, they will say, the older ones with lower amps will tell you minimum of a 14 American wire gauge wire size. The newer ones are at 12, and you can see that the maximum current that you want to run through a 14 gauge wire is 15 amps, and it's 20 if you have a 20 amps if you have a 12 gauge wire. So be mindful of that. If your application is higher, you will need to go with a larger wire size. And so just be mindful of that. These ratings are so that you don't get the wire so hot that it melts the insulation, and then the wires short to each other, and then you have a spark fire hazard, those kind of things. There is a nice little link here that you can look at for wire size and amp ratings, and actually do some calculations for voltage drop as well. That's more of an efficiency thing. It's the amp rating on the wire that's the safety concern. And then fuses, we recommend, let's say if you have a 8 amp load, then your standard fuse sizes for automobile fuses are like 5, 7.5, and 10. So you would want to go step up if your load on, say, your fan or whatever, or your lights you were running was 8 amps on that load, you'd put a 10 amp fuse. So that's the next size bigger, but use a wire size, at least 14 gauge, that could take 15 amps. So you've got some margin in that. If you had any kind of a fault in the system to draw more current, it would blow the fuse before you melt your wire insulation. And so we recommend putting those on the positive lead. And then let's say you have a 5 amp load. It says it's rated at 5 amp. I wouldn't go with a 5 amp fuse because you'd constantly be just barely tripping that for a second or so. When it first turns on the load, you get a little overshoot on your amperage, and then you can blow that fuse when it really didn't need to. So if you had a 5 amp load, I'd step up to a 7.5 amp fuse, but then have a wire size that can take 15 or 20 amps on it. Now that we do have some links here, and I will copy these into the chat here in just a moment. But there's Missouri Wind and Solar, has a lot of good stuff. Heating elements. I do want to show you the heating elements on this site. There's Arizona Wind and Sun. These all have really good prices for solar panels. They all have batteries and charge controllers. Your charge controllers, some of them are multiple voltage. So you'll hook them up to the system and they'll sense whether it's a 24 or a 12 volt system. Others are specifically dedicated to a certain size. The Arizona Wind and Sun has some larger pumps that get into some good sized ag applications. There's Unbound Solar is pretty good as well. The Solar Biz out of New Mexico. And then for auto parts, you can go to O'Reilly's. In fact, one of the things that we do with some of our solar panels too is we went to O'Reilly's Auto Parts and just got a USB connector, a little inverter that you screw in under your dash, and it's got the little inverter to step down from 12 volts on your car or your truck to the 5 volts on a USB output to charge your phone or any other kind of USB device. So those are real easy too. We literally just have some solar modules where we screwed one or more of the USB converters onto the frame itself, just pre-drilled some holes, screwed it in with a metal screw. We're good to go. And then you can set that up anywhere and charge USB devices. But auto parts stores are a lot cheaper for going, if you're looking at low cost fans, you just want a basic fan that runs at 12 volts. Look and see what they've got at the auto parts store. Jegs being a really good online one to check out.
Rich, we do have a question.
Okay.
And it's just concerning, does the weight of the batteries affect the longevity of the storage, and what are the cost of batteries in a fuse?
Yeah, so the fuses are very cheap. The batteries, a lot of times, are the most expensive part of your system, like on a cabin system. You will want a big enough battery and enough solar charging such that you really don't want to ever draw your battery down below 50% of full charge. You can do that, but it shortens the life of your batteries. Now, lithium, the newer lithium batteries, those are great. You can draw those down many, many times really deep, but they're also a lot more expensive. But any kind of a battery in your system, you'll see there's your standard car, truck battery, your engine starting batteries. Those don't like to be drawn down hardly at all. Then you'll see stuff that's labeled as RV Marine Deep Cycle. Those aren't true deep cycle batteries, but it's what's sold with your travel trailers and on your boats. And you can draw those down some, but they're still not very robust. If you go to one of the websites that I list here, they will have legitimate true deep cycle batteries that you can get. Some of them are in 12 volt configurations, but you can also, if you need really big battery banks, you might need to step down to a bunch of big 6 volt batteries or a bunch of huge 2 volt batteries. In my house, I actually have 12 2 volt batteries. Each one weighs 156 pounds. But that's the life of my batteries is 28 years. It's expensive, but also when the 28 years is up, I will probably replace with lithium batteries. But yeah, it's going to be the most expensive part of your system. Your fuses are really cheap. So that's probably the lowest cost in your system, even lower cost than your wiring. What's the cost of a deep cycle battery? You're looking at like the small one we showed you in the video with James. I think that's about $150, $180 on that one. It depends on where you get it. With shipping, it might go up to 200 on that battery. Yeah, they get kind of pricey. And that's the nice thing about golf carts. If you know anybody with a golf cart, they've already had those sunk costs in their batteries anyway, and they've been plugging them in. So this way, you put a solar panel on the roof. Not only do you not have to plug into the grid and use that power, but the whole time you're driving around using it, you still have it getting some level of charge from whatever amount of sun is hitting that solar panel on the roof. The only thing to keep in mind is wherever you stop, park it on the sunny side of the building. Or if you're actually out on the golf course, don't park it under the tree, park it out in the sun. That will actually extend the life of your batteries because they never get drawn down as much as if it only got a charge when it was back at the maintenance shop at the golf course. Let's see, longevity. Tricia asked about what's the longevity of the replacement panels. So the PV modules, just about everyone you get has a 20 or 25-year warranty that they will still produce 80% of the original specified power output after that 20 or 25-year warranty period. And so they lose about 1% per year. So we really see that there's a second 20-year life in a lot of these modules. Now, there's a few manufacturing practices in some of the earlier modules that were out there, or some of the later entrants, some low-cost Chinese manufacturers that were only in business for a couple of years. And from our testing, we'll be able to know, was there anything problematic with their methods of manufacturing that we believe would be a shorter life. But in fact, how we do this is we don't actually sell these modules. We can't sell them, but if you make a donation, and that donation is about 30 cents a watt for the rated power in that module, you can get one of these used modules. And we still expect them to last another 20 years, maybe even longer. The one thing that we would ask is that you let us know of any problems that you experience, because we do track this second life aspect and performance of these modules. Let's see, any other, I think.
Yeah, we do have one more question. Are there a lot of these that are going into the waste stream?
So when people upgrade their systems, if they don't have any place to put them, then yeah, they'll go to the landfill. In some cases, they'll go to an aluminum recycler who all they will do is remove the aluminum frame and then just landfill the rest of the module. Now, all the modules we have here is that all the ones we have available here are silicon based. We don't have any that are thin film. Thin film have some different materials in the components. We're still trying to figure out what we do with those. But the materials from just the silicon based, there was a nice study done out of a consortium in Europe that has one of their US members is Garvin Heath at National Renewable Energy Labs in Golden. And their study showed that as long as you dispose of these in a conventional landfill, there is no environmental impact. The leachate liner that is in a landfill should protect any trace amounts of lead solder that are still in there, even if the modules are broken. Now, what we would really like to see, one of the things we do is we're trying to divert this equipment from the landfill, give people another option, and we see that highest value option as being putting them back into use, making energy. A downgraded option would be recycling, reclaiming the raw materials. Right now here in the US and even in Europe, they don't have the full capacity for recycling at economic rates to handle the oncoming waves that we see coming by, say, 2027, 2030 is when we'll see these first utility scale solar farms getting decommissioned because the power purchase agreement has ended for that 25 years of power sales. So what do we do with these early 1 to 5 megawatt solar farms? That's what we're trying to buy some time and work with the industry to plan and get that infrastructure in place so that what can't get reused, and even our modules eventually, there'll be that threshold of there's more value in the reclaiming the raw materials than there is in the remaining power output. We don't know if that's 20% remaining output, 30%, whatever. We're going to figure that out. That's part of my doctoral studies. And then someone asked, like, do people need to apply to Equitable Solar to get a panel? Just send us an email at the, in fact, I need to add our email into the chat if that hasn't gone in already. But we do have some stuff. You let us know what your application is, and we can let you know what we have for 12 and 24 volt modules. Yeah, thanks, James. I did want to show one thing on the Missouri Wind and Solar, just for people doing stock tank heating. And let's see, we've got it here, is you'll see in here on their DC water heating elements page, there's a couple different versions. This one has an adjustable thermostat, which is kind of nice. This is a single heating element. This is a dual. Let's come in here and choose some options because I want you to just see what it shows on the options. And it's like this one, you can see it's a 12 volt or a 48 volt. So the 12 volt version, you can see will give you 300 or 700 watts, depending on how you you have two different options you can order. The 48 volt version, you can get up to 2000 watts. Now, if you have 48 volts, if you're not giving it the full amps to hit that 2000 watts, you'll get something less than that, and that's okay, but it will still work. But you would need, say, 2 of our 24 volt modules in wired in series to get you that 48 volt output. I thought there was some that, I think some of these, if you pull up the specs, you can also run them in 24 volt mode, but it's just not as efficient. Let's check this one out too. And you can see the bulkhead fitting was right there listed as well. And so this one is, yeah, you've got 24 volts on this one, but the 24 volt version will only give you 300 watts, whereas if you go the 48 volts, you're 600 or 1100 watts. Now, in here too, if you look at them, if you buy the 48 volt version, there's a way to wire it up in a lower voltage, but your efficiency drops. So I would recommend getting the right voltage figure out what you want to heat up, do your calculations on BTUs and your volume of water and that kind of stuff to figure out what temperature you're kind of working with for overnight lows and what your water volume is and what you want to get it up to during the day. And that will kind of tell you how many watts you need. But that's all I wanted to show there. There is, oh, and then, yeah, on the, will this load up? Let's refresh it here. On the electric fence charge controller, if it will load up the screen, it seems to be going very slow. For the electric fence, you will still need that a solar panel. That electric fence, you would have already bought a 12 volt battery for it. You will then need a charge controller in between your module and that battery. If you wire it up directly to that battery, the module is just going to blindly force power into that battery, even when the battery's full, and that can shorten the life, damage the battery, not immediately, but it'll take years off the life of that battery. And so you'd get a 12 volt charge controller, and it will sense. And if the battery's charged up, it will stop any more current coming off of that module. But as the battery starts going down, it'll let the solar panel top off the charge there. So I'm going to stop sharing here. And we're at 7 o'clock now. Wow. James, what did I miss?
Great presentation. Nothing.
Was he-
Sorry, I was taking that as a pun, Rich. I think the one thing I was just thinking is that we've been able to, by collecting these via donation, it allows us to help cut capital costs of projects. I think that's one of the biggest ways that we can help facilitate new installations and keep this equipment going is by helping to reduce the overhead associated with the panel cost. If it's just a roof system, it can be as simple as just a inverter, which we have some of as well, and racking equipment. And so it really just helps us be able to introduce solar to homes and businesses a little bit easier.
And so I did see a question coming across from Tricia, and she, in fact, someone was asking to, Tricia was asking about cost of installation. So ESS for these kind of applications, we won't be doing the installation. You'll need to do that yourself. We find that like ranchers and farmers are very much do-it-yourself kind of people, so they're a big part of our market. A lot of this stuff is pretty easy to learn yourself as well. Although there are workshops you can attend, you could come out for our 6 or 8 hour workshop that we do once a semester and get some basic hands-on skills with stuff that way too.
And then Rich, what about the couple of projects? So what did those end up? They're pretty comparable over the.
Right. So they came in pretty low. So we did the ice rink we did a 5.5 kilowatt system on our the ice rink here that the city runs, and that came in at $1.35 a watt installed because we had donated railings, donated modules. We did have labor and permitting and a new inverter we needed, but we got that one done super cheap. And then there's one we're doing for the Colorado Energy Office, a pilot project with them on a home that's done the weatherization assistance program. That's coming in about 175, 180 watt. So still for the size of the system, that's a 4 kilowatt system there. And for the size of the system, that's very low cost too, because we have this donated equipment and we do the my labor and stuff like that is for free when I help out the installer. So we find that installers are really eager to work with us. We still want them to get a decent paycheck, same with our electricians, but at the same time we can kind of package things and figure out how can we get the cost as low as possible to help out these low income households.
Well, it is 7:03, so I'm going to wrap this up, but thank you everyone so much for coming. And if you have any more questions, I'm sure Rich or James would be happy to answer them via email. I see that James put that in the chat. Rich, did you also want to put the website in the chat really quick?
Yeah, let me also, I'll throw the links of, I'll send the website link, and then I'm going to add the websites for purchasing. Let's do this to everybody. If you want to go shopping for components and stuff. So here's our specific page on the Cold Harbor website. And then here is some links for shopping for components. And we'll kind of stay on for a few minutes just in case anyone needs to copy this out of the chat. Give them a minute or two to copy that.
Yep. And this has all been recorded and I'll be uploading it to YouTube. So if you find our YouTube page, Cold Harbor Institute, you'll be able to see this. Feel free to share it with any of your friends and colleagues. If I have your email from registration, I'll be sending you the link as well. And Yeah, so thank you all so much for coming to another one of our spring webinar series, and have a great night.
Thanks, everybody.
Thanks, Jenny. That went really well.
I think so too. Good job. I learned so much. Did you get the batteries?
Yeah, I did. Boy, talk about wasteful packaging.
I
Goodness, it's
know.
like
I want to email them.
yeah,
I thought
it's
they were
like
going to be way bigger because of
it's like
how
D
big the box.
minus on the on that. So the packaging just like crazy.
I know.
Yeah. But yeah, appreciate you getting those. Oh, and then it looks like you threw in the 2032 batteries as well in the bottom there.
Yeah, you wanted 8, 2 packs of 4, right? Is that okay? Cool. Well, I don't know if either of you who are still on have any questions, or if you're just stepped away from your computer right now.
Yeah, they're cooking something up on the stove top. Good. All right. Well, thanks a lot, Jenny. Oh, there's Jeff.
You
Hey,
guys did
Jeff.
great. You guys done great. It was really nice.
Yeah, it looks like you're back in Taos, huh?
I'm in Beck and Taos. Coming up to Gunnison this weekend though. So yeah.
Here
Great.
all next week for our undergraduates and our graduates finishing up. So
You will be there too?
yeah, all week. Yeah.
Okay, me too. Me too. Let's get together, and this is really nice. This is great what you're doing.
And you said that your partner still would like to chat about solar too. So maybe I can make I was going to make a road trip down to Albuquerque anyway to visit some friends who are fully vaccinated. And so maybe I can just drop by Taos on the way, take that route instead of the I-25. And
when are you thinking?
Here, I don't know, like maybe before the May 20th. May 20th, the day of our staff retreat, I've got jury duty, so I can't do it then, or it'll be like after. We'll see if I get snagged for a jury or something, but it'll be just after that. But I would like to get on the road and hit some trails, that kind of stuff.
Good. Yeah, no, let's talk, and it'd be great to have you drop into Taos.
All right. Well, I'm going to log out here. I'll see you, Jenny. Thanks so much.
Thanks. Bye-bye.